we have this event where a whole bunch of us will take pictures of the moon at the same time, and we live all over the world in different areas. This most recent event was 23 of our members, and you can see on the map there how it's all the way from United Kingdom to Australia. Now, on the globe, these are essentially antipods. That means they're opposite sides of each other. And they can see the moon. Now, I ran the results through astronomy software to make sure that, like, what does the globe model tell us? The globe model tells us that all 23 of these positions should be able to see the moon at the exact same date. Now, is that possible, though, in terms of practical reality, geometry, and just math? I believe the globe model. The globe model is telling us that yes, we should see these, but the globe model's false. It falsifies data to try to replicate the real life flat Earth. So the reason why I wanted to run these results through the globe model is to see what they're actually trying to justify. Let's look for the lowest. And so just so you're clear, what this means, this is the angle from the horizon. So the first one, Newcastle, you see right there, that tilt is 6 degrees above the horizon. So that's been verified too. This is the 629 115 UTC, Newcastle, Australia. So I verified that the globe engine we're using is correct. Newcastle's at 6 degrees from the horizon. So understanding that, here's where it stops making sense. How can that be possible? So you understand what I mean, right? There's an example of what 5 degrees looks like. And even 10 degrees. But let's stop playing this globe and let's focus right in on this right here. Can we zoom out? Sorry, it's taking a little bit. It's a slow graphic because it's really big. But what I'm trying to show is that over a long distance, even a small angle, like 5 degrees, becomes really big. See, you see what I'm trying to show you, right? Because the moon, it's millions of miles away. So you have to remember, what I'm drawing here is actually going to be about 400 times smaller than what I even drew on the screen. Because the moon is 400 times smaller than the sun. And 400 times farther away, so they just look the same size. But you see how that angle completely bypasses what we're looking at. Like, it doesn't make sense. For the globe model to be justified, the angle would have to be 0. Because even though the object is right above, you can justify seeing it at a 0 degree altitude. Because it's so far away, it's just like turning your head to the side. But where it falls apart is when you have anything's like 1 degree and it falls apart. It has to be exactly 0 or it just doesn't work at all. And that's how a group of people collectively, we can debunk the globe model using their model. This is the VSOP 87 Novak C. You can't question this. The source code's available as well on my website if anyone wants to take a look through this, and you can verify it yourself. So I verified the code with Stellarium Globe software to see what is the actual altitude of the moon, and it's 6. We know that. So then we know that this is also all true. And we're just being conservative here, using angles of like 5, but some of these are even higher. The idea is that it's just not possible. You just can't. So that makes sense, right? It's this right here that is the issue I have, the geometry of how it's supposed to work. So sure, the globe model says that we should be able to see the stars or the moon, whatever, at a certain time, But is that actually possible? And the answer is no.